Okay, so now let's consider the problem. X squared equals 3. So I have a number x multiplied by itself is equal to 3. And I know this number is positive. This is given in my problem, okay? I want to find a positive number with that, such that when I multiply by itself, I end up in 3. We're gonna call this number square root of 3, and it's a irrational number, so it's gonna be the decimal expansion will be forever without any periodic part, and we can approximate by 1.7. There are of course more digits, but I can truncate and approximate. This is approximately 1.7 with one decimal place. The idea here, we can use Pythagoras theorem in this triangle. This leg here has a measure of 1. This leg here has length of square root of 2, which is square root of 2 is a number that multiplied by itself is 2, and square root of 2 is approximately 1.4. Again, I have a decimal part here. I could put more decimal places here to be this is a better expansion, but let's take it 1.4 only as an approximation. So if I use Pythagoras here, x is my hypotenuse, so hypotenuse of squared is equal to this leg square plus this leg square, but here the square of the square root of 2 is 2, right? Taking the square root is the opposite operation as squaring, so the square of 1 is 1, so x squared, just repeat here, 1 plus 2 is 3, x squared is 3, and I'm back to my problem here. So my solution is square root of 3. So if this leg here is like 1.4, this other leg here will be approximately 1.7. Okay? So in a square, here I consider the square, perfect square with side 1, 1, 1, 1, 90 degrees, 90 degrees, 90 degrees, 90 degrees. I take the diagonal, 45 and 45. And the diagonal, the length of the diagonal is the square root of 2, okay, which is like 1.4. It's like 41, approximately 41% bigger than the size of the side of the square. And we can pick up, for instance, one of these triangles here, this triangle here in red, and apply Pythagoras to this triangle in red. The hypotenuse is square root of 2 square, this leg is 1, I square, the other leg is also 1, I square, and of course I get 2 equals 1 plus 1, which we know is true. Okay, so this diagonal here has to be square root of 2. And you can see why we call square root to square root. It has to do with the geometry of the square. So in general, we write square root of a as a raised to the power 1/2, right? Why is that? Why do we consider that? Well, because when we say we have square root of a times the square root of a, and we know that's a, is the number which multiplied by itself is a, right? So if I were to think, okay, this square root of a is a to the power n, this square root of a is a to the power n. This is a to the power 1. I know that to multiply two numbers with the same base, I repeat the base and add up the exponents. N plus n is 2n. So a to the power 2n is equal to a to the power 1. So the 2n has to be equal to 1. 2n is 1. And then n has to be 1/2. So the exponent here has to be 1/2. Okay? So a to the power 1/2 square is what we do when we have this and this, we multiply. 2 times 1/2 is 1, or just a, right? Okay. So all the rules we learned before also apply when you have this exponents as fractions. As fractions 1/2. For instance, here I'm considering a to the power 3 halves. But 3 halves is 2 halves plus 1 half. So if I multiply these two numbers, I repeat the base a and add up the exponents. 2 over 2 plus 1 over 2 is 3 over 2. So this part is correct. But a to the power 2 over 2, that's just a to the power 1. A to the power 1 is just a. And a to the power 1 half is the square root of a. So a to the power 3 halves is a times the square root of a. Okay? Surprising. A to the power 5 over 2. 5 over 2 equals 4 over 2 plus 1 over 2. Okay, if I add up 4 over 2 and 1 half, I repeat the denominator 2 and add 4 plus 1 is 5. So I have this. 4 over 2, of course, is 2. So this is a square, and a to the power 1 half is the square root of a. In general, you can do that for larger numbers. A to the power 21 over 2. 21 over 2 equals 20 over 2 plus 1 over 2. Right? 20 over 2 is 10. A to the power 10. A to the power 1 half is just the square root. And here I don't put anything, but when I don't put anything, actually means I have a multiplication here going on. I can leave without symbol. When I don't put any symbol, it means I'm multiplying the things. How about this? 8 to the power 3 halves. It's 8 square root of 8. Okay? I'm using this formula here. Something to the power 3 halves is something times the square root of something. 8 to the power 3 halves is 8 times the square root of 8. But now this 8 here is 2 to the power 3, and we can simplify that because this is just a to the power 3. We can think of this as a square, right? 2 to the power 1 times 2 to the power 2, this is 2 to the power 3, which is 8. And now I can separate this square root this way. 2 square root times 2 to the power 1 square root. Always multiplying here, right? I'm not writing the symbols, but it means multiplication. 2 square root, so raising this 2 to the power 2 and then taking the square root cancels out. This term here, this factor here is just 2. And this is the square root. So I have actually 16 square root of 2. So some nice algebra here to simplify our expressions. Okay? Hope you enjoy. See you next time. Bye bye.